Welcome back, ladies and gentlemen. We are on 7.5 again, but now we're doing day 2. So, ladies and gentlemen, boys and girls, I'm going to go ahead and say, let's go ahead and write down we don't need a calculator, all this goodness right here. And then we can go ahead and talk about this. And then the same thing with this one down here. So hopefully, ladies and gents, you hit pause and you filled those out. If not, go ahead and hit pause now and rewind. And make sure you got it down, some diagrams made before we go and get this party started. All righty. So when I think of this, ladies and gentlemen, notice that I have right here side to side. And so if I look at this, and I have it kind of highlighted here in my different colors, as I can show you what my sides are. So to start that, I have a shared angle, and that's what I definitely always look for first, is that shared angle. And that's what's equally as important are these parallel sides right here. So parallel sides. So when that happens, ladies and gentlemen, that's a dead giveaway that you're going to go ahead and do side to side. So if I do one side, I call this the left or the top. It really doesn't matter. But notice that this part was in blue, so I'll go A, B is to this pink side here, B, C. So I'll call this the left or the top. And to the other side here, we're going to go ahead and it's tough to see now, but it was purple. So this is purple, AD is to DE. And so that's going to go ahead and be a proportion that we can cross multiply and solve with, known as side to side. Those parallel lines, that shared angle is uber important. Now, this is kind of blank, and so the idea is that it's converse. Remember, converse, and we usually use that to prove parallel. So what that means, it says, is if there's a shared angle, and we've talked about that so far, right here, and we have the same relationship that we listed above, that AB is to BC and that AD is to DE, then we could say that BD is parallel to CE. So again, converse usually means to prove parallel, and that's what we did here with our converse. Alrighty. So, ladies and gentlemen, what's the difference between 7.5 and then our corollaries? Is they don't make a triangle. Notice that this is open, okay? But really, can we just keep on going and say that they make a triangle? Absolutely. So even though they're open, they still can make the triangle, which means that our side to side still works. So this side right here would go to this side down here. And notice, even though we don't have our shared angles, I do have my parallel lines. So AB is to BC, which is my top part. And then the other sign is DE to EF. Now, again, it's top and bottom here, but there's no reason that this isn't flipped to go ahead and look like this. And then I would do this side to this side. So that's why I call it side to side, to make it easier. Now, the second corollary to that is what I call congruent. Looks like I missed my space in here. Apologize. But congruent side to side. That says if we have the same exact diagram, but if one set of sides are going to be congruent, that means that the other set. So if one set is congruent, notice I have tick mark, then that same is going to be the same relationship on the other side. So the other side is congruent. But notice that this is 2 tick marks. Okay, so a big rule is they're not all congruent to each other. It's the sides are going to be matching up. So the blue side here matched up, and then the pink side here matches up. Cool. But today's notes is really just side to side. So if you need to go back and look at those, please do so. Hit the pause button, hit the rewind button, but let's sally forward. So I've gone ahead and I've already labeled my diagrams to make this easy, including putting what I need to find. Okay, so I just went ahead and labeled, as we can see right there. Notice that X is really this entire side right there. Okay, so I'm going to keep this side here in blue, and then this side here, I meant to give it a different color here. Come on, yellow highlighter, boom. So we can see the side to side. We can see our parallel, good stuff. We have our shared angle here at X. So I'm going to start at the shared angle. It makes it a lot easier if you start at that shared angle. So if I go on the blue side, I'm going to go X to M as M is to Y. And then on the other side here, we're going to say X is to N down here as N is to Z. So for the most part, we can just plug this in. So this is XM, which is 4, is to, I'm going to leave that blank for just a second, and then 6 is to 9. So how do we find out what this piece is because there's nothing there? So the whole piece is X. So if I were to rewrite this, the whole piece is X. The whole thing is X. I'm going to draw it over here so we can see it. And then if I set it into pieces, if from here to here this is 4, this is going to be the rest. So how would we write that? The rest is going to be X minus 4, because X represents the whole thing minus this piece, 4. So before we cross multiply, let's reduce this fraction to make our lives easier. 4 is to X minus 4 as 2 is to 3. So we're going to put parentheses around our binomial here. Cross multiply. So 2 times X minus 4 is going to give me 2X minus 8. And then cross multiply this way. 4 times 3 is going to give me 12. Now we can just solve. So plus 8 plus 8. So I get 2X is equal to 20. So X is going to be 10. All righty. So, ladies and gentlemen, boys and girls, hopefully we're feeling good and ready to rock with that one. It makes sense. So, let's double check. How do we double check? So, this is my scale factor here. It was 6 to 9, right? So, if this part was 4, that's the top, the whole thing is 10, so that means this has to be 6. So, remember, these all need to reduce to the same number. So, since they all reduce to 2 to 3, that means that this X that we found is the correct answer. So plugging them back in and double checking your scale factor is how you're going to go ahead and be able to check your work, which is super nice. All right, let's go to this next one here. So we have our shared angle. Boom. I have my parallel. Bazinga. So one side, that's going to be XM is to MY. And then our other side, again, side to side, starting from our shared angle, XN is to NZ. All righty. So if I look at this first part, it says XM is 2, so 2. And a little bit different here, if this whole thing here is 10, and this part is 2, then 10 minus 2 means that that's going to be 8. So 2 is to 8. As 6 is to X. Just like we did in the previous example, we're going to reduce this fraction. So we're going to get 1 over 4 is equal to 6 over X. Cross multiply. 6 times 4 is going to give me 24. And then X times 1 is going to be X. So X is 24. So let's double check. So if this is 24, and I do side to side again, 6 is to 24, as the other side there, yellow, was 2 to 8. So if I reduce both of those, I get 1/4. Boom! Check. So 24 works, and it checks out. All righty. So on this next one here, number 3, notice it doesn't complete. Eventually, these will make a triangle, but that's not the point. The point is that we can still look at this relationship even though we're not at the triangle yet. So notice that we have our parallel, so we could do side to side. But on this side, we notice boom, boom, that those are congruent. So that means by our lovely corollary number 2, that if one set is congruent, then the other set is congruent. So I can go ahead and say, boom, that these are the same as well. So to solve for y, I'm going to go 12 minus 3y is equal to 16 minus 5y. For one side to side there on the left, and then on the right, we'll get 1/4 x plus 6 is equal to 2x minus 29. And we just have to solve them individually. So let's go ahead and get this party started. So biggest negative y there, so we're going to add it to the other side. And so we get 12 minus 2y is equal to 16. Well, minus the 12. That should be a plus there. So 2y is equal to 4. So y is going to be 2. And we could plug that back in to make sure we are all good. So 12 minus 6, because 3 times 2 is 6. So 12 minus 6 is going to be 6. 16 minus 10 is going to be 6. That checks out perfectly. All right, let's do this one. Now, I have a 1/4 x. So we can solve this a lot of different ways. One fun way is that because this is an equals, I can multiply everything by 4, and I'm talking about every single thing. And when I do so, ladies and gentlemen, that that fraction is going to go away. So if I go to this first term, that's just going to be 4 over 4, which is a 1x. And then if I go to the 6 there, that's going to be 24. And then if I go to the 2x, that's going to be 8x. And then that's going to be 4 times 29. So that's going to be minus 106. Let me double check that with my handy calculator. 4 times 29 is going to be 116. I thought something was funky, and we fixed it. Now we're good to go. All right, so let's solve a So minus 1x minus 1x. And we get 24 is equal to 7x minus 116. So 7x, when I add 116 to both sides, is going to go ahead and give me 24 plus 116 is going to be 140. And so x is going to be 20. Boom, boom, boom. Cool? Alrighty, so ladies and gentlemen, we are going to solve for the variable. And sorry, ladies and gents, it just jumped because I did this problem wrong. And so to be perfectly honest, because I didn't read my directions clearly, CA is 10. So that's this whole side right here. So if this part is 2, then that means this is going to be 8. I got a nasty fraction, and I'm like, something smells funky. So let's do our side to side. Again, we're going to start with our shared angle here. So, and then again, read our directions, because I forgot that, and make sure you solve for t and plug it back in. So on the green side, I'm going to get 2 is to 8. And then on the other side, I'm going to get t minus 2. Let's do that in blue since that's what it is. So t minus 2 and t plus 1. Now, because these are binomials, as in 2 terms with a minus or a plus in between, you can't cancel out like that, okay? But I can reduce on this side over here. So 1 over 4 is equal to t minus 2, t plus 1. Cross multiply here, 4t minus 8. How did we get that? I skipped some steps, so let's check. So we get 4t minus 8 when I distribute. And then going the other way here, 1 times t plus 1 is going to give me t plus 1. So I'm now going to go ahead and move this t over. I'm going to get 3t minus 8 is equal to 1. Look, I'm going to get a nice, easy number as opposed to a nasty fraction. So when I divide both sides by 3, t is 3, which is great. That's part of it, but I need to plug it back in here right there. So 3 minus 2 means that CE is going to be 1, and that's the other part. So in this case, I have 2 answers. Gravy? Alrighty, so normally I would say take this next one for a spin, but it gets a little saucy, especially since we have 3 triangles. So let's do this one together, make sure we're golden, pun intended, as we've been using some gold colors. So I'm going to solve first for a couple of different things. So, and a piece of information not quite on there yet, and I needed to make sure that we throw that in there, is QW. This whole thing here is 15. So that means that this part is 3. So remember, when you do a proportion, A is to B as C to D, those are 2 fractions implying 2 triangles. Here I have 3. Technically, we could probably even make more, but we'll go ahead and call it good with just 3. So 1, 2, 3. I meant to make this one an orange. 3. There we go. So I'm going to use 2 at a time. So the first one, to find my x, QR is 2 there, is I'm just going to use this baby triangle. So if I draw it right here, so Q, so this would be 2 is to 3. And then the other side, boom, boom, this is going to be 12, and this is x. So since these are parallel, I can make these parallel and go ahead and say, alrighty, let's do side to side. So this side is to this side. So 2 is to x as 3 is to 12. We're going to reduce this, so 2 is to x, and then 1 is to 4. Cross multiply, 1 times x, and then 2 times 4 going this way. So x is going to be 8. So let's double check our scale factor here. So 2 is to 8 going this way, as going this way, 3 is to 12, and that reduces to 1/4. So our scale factor is good. We're all set. We've checked it. X is equal to 8. It makes sense. All right, I'm going to erase this so I have more space. So now how do we find y? So now what I'm going to go ahead and do is I'm going to keep using side to side, okay? But in this case, my side to side is going to be just 2 triangles. This is going to be Q to S. So if I look at this Q to S, already highlighted here in gold, that means this is 10, and then this is 5, and then over here on this bottom one, this bottom right here is going to be 15, and then what we're looking for is going to be this last part right here, which is y. So we're going to go ahead and do our famous side to side. So 10 is to 5 as 15 is to y. Let's make that 15 and y the blue, since that's how it goes right here. So 15 is to y. So I'm going to reduce this one right here. So that's 2 to 1. That's 15 to 2. Cross multiply, so that's 15. Cross multiply, so this is going to be 2y. So y is 7.5. And we get a fraction. At least it's a nice fraction. Gravy? Alrighty. Last but certainly not least here, sports fans, we have our side to side with some algebra that might get a little saucy. So let's make sure we are all good. So again, we are always starting at the shared. So 12 is to 3x minus 2, as 15 is to 3x plus 2. Alrighty. So we are trying to prove right here that those are parallel. So for what value is going to make these parallel? Okay. And so we're going to assume, so to prove parallel, to solve that, we're going to assume it's parallel and solve, which is why we did side to side right here. This is the one side. This is the other side. When we find the x that works, that's going to make this proportion work, which is our corollary, our converse right here. So remember, this has to prove true before it's parallel. So that's why we're doing what we're doing. So cross multiply there. So 3x minus 2 times 15. And then we'll go this way. 12 times 3x plus 2. We're going to distribute. So 45x minus 30. And then we'll distribute over here. And that's going to give me 36x plus 24. So let's minus my 36x to solve. And so we're going to go ahead and get 9x minus 30 is equal to 24. So 9x is equal to, when I add this 30 over, 54. And then we're all pretty good at this, but 54 divided by 9 is going to give me 6. So when x equals 6, then BC is parallel to DF. Cool? So that's the end of it today, ladies and gentlemen, boys and girls. Hopefully, I just want to make sure I'm still recording here. Okay, we're good. So it's all side to side. Okay, all different versions of side to side. So start with your shared point, as we circled right here. Shared point. Okay, make sure you have your parallels. Or if you're proving parallel, like what we did right here, okay, you're still going to assume that they are parallel and then just work backwards. Last but not least, if it's down here and it's congruent, well then, my friends, it's the left side is congruent and the right side, but not all of them. So this is Mr. Naughton saying we'll see you next time. Take care, sports fans.